Next topic is pH. On the soil test form, I like to talk about pH because I think it's one of those things that is not well understood, even though we all think we have a general working understanding of it. So, for starters, can anybody tell me what pH is actually testing?
Potential hydrogen.
Not potential hydrogen.
Yes.
Hydrogen's in there somewhere.
Hydrogen ion concentration,
In relation to
hydroxide ion concentration.
hydronium, yes, hydronium. So there's this compound that a lot of us have seen, we deal with on a regular basis. They say it looks something like that. People have heard of this one? HOH? Yeah. So they say you don't ever see just one atom of water by itself. Usually you see a bunch of atoms of water in relationship to each other. And water as a compound is somewhat dipolar. So when you've got a bunch of water molecules all hanging up together, they are the H and the OH will separate, and maybe this H will hook up with this O sometimes, and with that H sometimes. And this is basically, it's a big, let me use your term of choice, but they're not like monogamous. And there's never an even balance, right? Unless you've got a pH of 7. There's never an exact even balance of H's and OH's, unless you've got a pH of 7. And so what pH is telling you is what's the ratio of H's to OH's. So as I understand it, you got your pH, you got your H, and you got your OH. So a pH of 7 means you've got 1 H for every 1 OH. A pH of 6 means you've got 10 H's for every 1 OH. A pH of 5 means you've got 100 H's for every 1 OH. A pH of 8 means you've got 1 H for every 10 OH's. It's the inverse log of the hydronium to the hydroxyl ion or something. It's a logarithmic scale. It's one that increases for every number. It's increasing by a factor of 10, like a Richter scale for earthquakes. So when you're getting a soil test back that says you've got a pH of 5.5, and they're telling you you need to add calcium. Anybody ever had this experience? Got a soil test back, says you got a low pH, therefore you should add calcium. What's going on? Where is calcium in this equation? Calcium is not in this equation. Why is pH considered to be so god-awfully important? Anybody?
It affects the solubility of the nutrients and
That's
how
the
plants
idea.
take them up.
That's exactly the idea. All right. I got a little bit of space left over here.
It also affects the biology because bacteria and enzymes don't function at certain pHs.
So, two good points. One to be addressed, and then the other one. So there's this solubility index, solubility gradient. This was devised, as I understand it, in a laboratory. So let me just keep it around and use some glue. So here's the concept. You've got a test tube full of water, and you put a little piece of copper in the bottom of the test tube. This copper will become more or less soluble based on the pH of the water. So you got this gradient which goes 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8, etc. And the copper becomes most soluble in this range right here. 6.4 or 6.8 or whatever. Most copper is soluble in the test tube at that pH range. And interestingly, a lot of other elements are also most soluble in that pH range. The concept here is that the only way the plant could ever get its roots on some copper is if it's soluble, which is ridiculous. we are operating in conventional agronomy with an assumption that there's no life in the equation. That we're living in an abiotic test tube. It is true in a test tube, it's true that copper becomes more soluble in this pH range, but my understanding is that there are different species of soil life whose faculty is to go out and solubilize copper or solubilize potassium or solubilize zinc. And what they do when they're fed by the plant, when the plant says, I need copper, it makes food for copper solubilizers, it feeds them, they reproduce, they go out, they exude the acid or exude the base to solubilize that copper, then they digest it into their body, so it's not a simple copper ion, but it becomes a copper complex, an organic compound. And then when they die, 2 hours later, the plant sucks up that copper-based compound and uses it to build its body with. My understanding is that in the rhizosphere, in this area immediately surrounding the plant root, if you take a pH meter and you stick it right there and you watch it for 24 hours, the pH in that one spot can go from 5 to 7 and back to 5 in 24 hours in one spot. That the role of the soil life create the pH environment that they need to do their work, and they're constantly exuding acids and bases to raise and lower the pH to solubilize the nutrients that they're looking to solubilize and digest. So for me, I'm much less concerned about soil pH. I'm much more concerned about the full suite of elements being present. And just because you've got a low pH does not mean you necessarily need calcium. You may need magnesium. You may need potassium. Oftentimes, at least in Massachusetts, we don't have any local quarries that are calcitic lime. We have a lot of dolomitic lime quarries. So that means when people say add 2 tons of lime per acre, then you're adding 3 parts calcium and 1 part magnesium. And it doesn't matter. No one's paying attention to whether your soil needs calcium or needs magnesium or has too much magnesium, not enough calcium. These are the things that Albrecht figured out. Albrecht figured out that there's a ratio between calcium and magnesium and potassium that's really important. That only when you've got certain levels of these in relation to each other do things flourish. It's not about the basic pH management. It's much more about the levels and ratios of these different elements, which do affect pH. I feel like I'm saying a lot, and it's kind of complicated. And some people are giving me thumbs up. And other people are looking like, it's a bit much. I'm just going to have to be what it is, I guess. I can try to explain it differently. But this is my basic understanding about pH. pH is actually testing the H to the OH levels. When you've got high levels of H, which is when you've got a low pH, which is what is the background environment around here a lot. What that means is all of the elements that used to be stuck to the soil are gone, and there's a bunch of H's left. When you farm the soil out, when you harvest all the crops, what happens is the soil life will, pull off the calcium and replace it with a hydrogen, or 2 hydrogens in this case, because the calcium has a bonding, has a +2 charge. So it'll take out the calcium and replace it with hydrogen. And so the lower your pH functionally is the emptier your tank. You can have a big tank or a small tank, and it can be full or it can be empty. So the size of your tank is basically your exchange capacity, and the fullness or emptiness is the pH. Is that a metaphor that could work for anybody?
Yeah, you kind of explained maybe why the pH is so low in New England then, just because the soil was so...
It's worn and weathered.
So worn it out that it's just natural like that.
And it's much higher out west where it doesn't rain very much. It's been raining 30, 40, 50 inches of rain every year for 10,000 years since the glaciers left out here. And a lot of the structure and what was on the soil, and then don't mention when the settlers came and they cut down all the trees and tilled all the soil and destroyed the structure, stuff really started to leach out. So we have thin soils to begin with, and with what historical factors have been present, we have really worn and weathered thin soils. And so we just don't have in our soils a lot of those things that we'd like to have. which is why crops grow much better in California. Because they get a lot more nutrients, minerals in their soil inherently because they haven't been weathered out recently.